Sorry about the ending to the last one. We were taking 3 times 25 and then adding 30, and that is also 105 degrees. So we see that, yes, the two angles are congruent because their measures are equal, and we just showed that. Cool. So that's definition of congruent angles. Next one, because we have 2 more to get through, and not a lot of time to do that. So definition of angle bisector. Just like with Unit 2, we had definition of segment bisector. Angle bisector is not that different, and you've done the construction for it. So definition of angle bisector is just a ray, segment, or a line that divides an angle into 2 congruent parts. So I'm cutting the angle in half, and then I've got 2 congruent angles. Okay, we'll use this if we know what we see in the example, that a ray, or a line or a segment, bisects an angle. And if we know that, then the 2 angles are congruent, the 2 angles that are created. So one example here, ray BD, so we're looking at practice example 4A, ray BD bisects the angle EBC. Okay, if you see something like that, right away, you should just trace over the angle, EBC. So angle E to B to C. Use those letters in order. Then I see ray BD, so B through D, bisects this angle. Okay? So bisects angle EBC. We want a pair of congruent angles. The definition of angle bisector says that our angle bisector, that ray, in this case ray BD, cuts my original angle, EBC, into 2 congruent parts. So that means that I've got angle EBD, and that is congruent to angle DBC. Okay, so EBC was cut into 2 angles that are congruent, since a bisector cuts it in half. Okay, I would pause it and try the next one, and then check it to see if you're correct here. So take a moment and pause it. Okay, so hopefully you tried that, you paused it and then checked it. You're checking it right now. So this next one is angle BE, or sorry, ray BE, bisects the angle FBD. So let me get this to be a little bit skinnier. And so I see angle FBD, F to B to D. And then ray BE, so B go through E, and we start at B. That ray is cutting the angle that I highlighted in yellow in half, so into 2 congruent parts. So I see that this is the halfway point between these 2 angles. Okay, so that means that angle FBE, so this one, F to B to E, is congruent to angle EBD, since the angle is cut in half. Okay, moving on. Again, pause if you need to process that a little bit more. That's what's great about a video. We're going to go to example 5, and I went way too far. Okay, example 5, so turn the page to page 11. Page 11. Okay, and we're going to do this example. So we're going to let ray BD, so ray BD, bisect angle EBC. So this was one that we already talked about in the last problem. Okay, and so when we saw that ray BD bisected angle EBC, we already know that these 2 angles, angle EBD, is congruent to the other half that was created, angle DBC. Okay, using the definition we've already talked about, when I see that 2 angles are congruent, we know their measures are equal. So I'm using that thought process to say, oh, the measure, oops, sorry, I didn't see that. Measure of angle EBD is equal to the measure of angle DBC. And once I have that, EBD is the 7x minus 4. So I'm going to replace measure of angle EBD with 7x minus 4. And then I am going to replace this measure of angle DBC with what it is equal to, 3x plus 8. Okay, so I'm just substituting in the values that are equal to the measures of the angles I've written. Okay, so that means that 7x minus 4 is equal to 3x plus 8. So I substitute those values in. Once I substitute them in, now I'm just solving for x, which this example, that's all I need to do. I need to find the value of x. So to do that, remember I want to get all of my terms that have x in it on one side of the equation. So I notice 7x is on the left side of the equal sign and 3x is on the right, so I'm going to subtract 3x from both sides and I get 4x minus 4 equals 8. To get 4x by itself, I'm going to need to do something about this minus 4. So to undo subtraction, I need to add. So I'm going to add 4 to both sides. This negative 4 plus 4 gives me just the 4x plus nothing on the left. And then 8 plus 4 is 12. Last step here, I've got 4 times x equals 12. Well, to undo this multiplication on the left side, I need to divide by 4, which gives me x equals 3. And so since all I wanted to know was the value of x, nothing else, I am done. And then I'm all excited and I draw a smiley face because I know, yes, I'm done. Okay. So that is practice example 5. So that is definition of bisect. Bisect, you are cutting something, in our case here, definition of angle bisector, cutting an angle into two parts, two equal parts. Okay. So the third definition, theorem, or postulate I want to talk about is the angle addition postulate. Same idea as the segment addition postulate, except we're talking about angles. So this time, if I know I've got some point that's inside, so interior, inside my angle, I can have some ray going from the vertex through that point. Okay, so that would be like ray BD. With that, notice my whole entire angle is split into two smaller angles. So I see this red angle here with x degrees. That would be angle ABD. So that would be this part right here. Okay. And then I see this blue angle, that blue arc, and I see, oh, this is y degrees, whatever measurement that is, and I see that is the other angle, angle DBC. And this is a typo here. This should say M, the measure of, the measure of. Okay, we're talking about measures this whole entire time. But so those two smaller angles, if I put them together, it creates the whole angle. So remember, this is just saying one part plus another part equals the whole thing. Okay, so starting basic here with our practice example 6, we just need to identify the parts. So I see angle NOQ, so N to O to Q, this one right here, is 55 degrees. Okay, then I'm given that angle Q to O to P, so the other smaller part, is 70 degrees. When put together, and notice these angles are adjacent, I'm going to throw that word in there, these adjacent angles, when put together, I want to know what the whole entire angle is. So if I look at N to O to P, so angle NOP, what's that measure? Well, a lot of you could do this in our notes from section 1 and 2, and you would say, well, duh, just add 55 plus 70. Do that, and you get 125, and you would be correct. Okay, so I'm adding the two parts to get the whole angle. So 55 plus 70 is 125. Okay. Second example here, I see angle DEG is 124. So it's this whole part. The smaller angle over here, GEF, I don't know that yet. but I know the whole entire thing, DEF, the whole thing is 140. So I know the whole is 140. I know the part I don't want is 124 degrees. So I'm going to take the whole thing and subtract out the part I don't want. So 140 minus 124 gives me 16 degrees actually. And that's this part that's remaining, angle GEF. This is 16 degrees. Okay, if we use the segment, or sorry, not segment, angle addition postulate up above, it's like me saying that 124 plus the measure of angle GEF is equal to the whole thing of 140 degrees. Well, if I want to isolate the measure of angle GEF, we would say, oh, we need to subtract 124. So we do that, and then we get 16 degrees. Okay, doing the same thing with this third example, HJL, I don't know what this angle is, but they tell me that angle LJK is 60 degrees and that the whole entire angle HJK is 120 degrees. Okay, so again, that's like me saying measure of angle HJL plus this LJK, that's 60 degrees, is equal to the whole thing HJK of 120. Well, I want to get measure of angle HJL by itself, so I'm going to subtract both sides by 60, and I find out that 120 minus 60 equals 60. Okay, so that's just the basic. We're going to go beyond that, and you'll see more examples like 7 and 8. Okay, so I'm going to do example 7, and then if there's time, I'll talk you through example 8, but I'll for sure have that answer down. So example 7, find x if the measure of angle EDG is equal to x plus 96, sorry. Measure of angle EDC equals 154, and measure of angle GDC is equal to x plus 82. Okay, so the first thing, I would practice writing this angle addition postulate. So I see the two parts would be CDG, that's one part. The other part is this GDE. So those are my two parts. Okay, and so I'm going to add those together. So I'm going to say measure of angle CDG plus the measure of angle GDE equals the whole angle. And so in this case, that would be measure of angle EDC. So some of these I might have written out of order from how you see them. For instance, GDE is the same as this EDG, and CDG is the same as GDC. Okay. The part I highlighted in blue on the actual angle is this. So if it helps, you can put things in the picture. So like E to D to G, this is x plus 96. Sorry about this going in and out. I don't know why it's glitching on me right now. And then measure of angle G to D to C is x plus 82. And then I see the whole entire thing is this 150. Okay. So remember, it's the part plus a part equals the whole thing. So I'm going to substitute those values in. I see CDG, what I have written there, measure of angle CDG or GDC, same thing, is this x plus 82. And then this measure of angle GDE, same thing as EDG, sorry, is x plus 96. And then that's equal to 154. Okay, from there it is just an algebra problem. So I want you to pause it, finish this problem, and finish the next one, and check your really quickly practice example 7. You should get x equals negative 12. Looking at example 8, look at my notes, part plus part equals whole. You get x equals negative 8, final answer of 110 degrees, x won't always be negative.